Do you feel that this year's heat is abnormal? It's not an illusion. According to the latest announcement of WMO, 5 years, there's an 80% chance of breaking the record. In other words, it may be even hotter. Airport runways have cracked due to heat. Even the Eiffel Tower has been tilted by 20 centimeters. In the Arctic, the warming rate is 3.5 times the average. But when we worry about the Earth becoming Venus 2.0, a more subversive scientific fact is that we are living in a long ice age, a relatively warm interglacial period. When will the next ice age come? To know the answer, we have to send you back to the Earth millions of years ago to feel the pulse of the Earth's climate and try to find the answer. Here, you will witness a magnificent and decisive period. It shaped the future of life on Earth and left the most exciting relics. It is the last ice age. This exploration will let you experience firsthand the extreme environments that life on Earth can endure. Over 100,000 years ago, many ecosystems on our planet were reshaped by huge ice sheets and the biting polar winds and the barren landscape. This was a severe glacial period. The cold lasted for thousands of years. With the end of this period, many representative species mysteriously disappeared, and the reasons still puzzle us. What you are experiencing now is not the first ice age on Earth. In fact, the Earth has experienced 5. So what do they have in common? The so-called Ice Age is a long-term extremely cold period on Earth, usually lasting for millions or even tens of millions of years, which led to the surface of the Earth being covered in glaciers. The last Ice Age we often talk about began about 2.6 million years ago in the early Pleistocene. You may be surprised, we are still in it. Any ice age contains 2 periods: cold glacial periods and warm interglacial periods. In fact, we are currently in is the latest interglacial period. It has lasted for 11,000 years. So when people mention the last ice age, they often refer to the last glacial period. It was before the current interglacial period. It started from 115,000 years lasted ago until 11,700 years ago. Another fact may surprise you. During the last glacial period, the global average temperature was only 6 degrees lower. However, even if it's just a single-digit difference, the global temperature change has far-reaching impact. When we say the global temperature dropped by 6 degrees, a huge heat loss from all oceans, land and atmosphere. During the last glacial period, most of Europe and North America were dominated by 2 ice sheets, the Laurentide and Fennoscandian ice sheets. The limited water on Earth was locked in these ice caps, so the average sea level was much lower. The land was mainly tundra vegetation, distributed on the dry grasslands. No single factor can explain why the Earth fell into such severe cold, but by observing the Earth's orbit at that time, many problems can be solved. In the last century, Serbian scientist Milankovic, he proposed the hypothesis that the long-term changes in the Earth's position are a powerful driver of climate, which can explain how ice ages are triggered. Milanovic studied 3 movements, which change the amount of solar radiation. This is the famous Milankovitch cycle. Orbital eccentricity, when the Earth is subjected to stronger gravity from Jupiter and Saturn, its orbit will become more elliptical. This cycle is about 100,000 years. When the orbit is elliptical, the length of the seasons changes most significantly, and summers are longer than winters. An elliptical orbit means that the Earth is at the aphelion in July, is farthest from the Sun. The solar radiation in July is about 23% less than in January. As a result, winter is warmer and shorter, and summer is cooler and longer. The axial tilt, which is the inclination of the Earth's axis. The more the Earth tilts, the more extreme the seasonal changes will be. This cycle is about 41,000 years, so when the Earth's tilt is small, the seasonal differences will be very mild, resulting in winter ice not melting in summer, and snow and ice may accumulate, eventually leading to an ice age. Axial tilt and the axis swing. Due to the gravitational pull of the Sun and Moon, the equator of the Earth will slightly protrude outward. It is not a perfect sphere. This causes the axis to wobble as it rotates. This cycle is about 26,000 years. It changes the contrast of seasons, making the season contrast more extreme or less extreme. The combination of these 3 cycles together affect the long-term climate of the Earth. They are quite reliable factors in predicting. However, shorter cycles are also important. They can enhance or weaken these effects. For example, the events throughout the last glacial period. There are the Dansk-Gardoshka events related to sudden warming, Eemian event, and the Henry event that caused rapid cooling. So here comes the key question. How do creatures that roamed our planet at that time, how did they adapt to these changes? What did they look like? How they lived? We mentioned that the last glacial period mostly occurred in the Pleistocene, from 2.6 million years ago to about 11,000 years ago. The Ice Age was the era of giant animals. The word giant is not an exaggeration. Some of the largest weighed up to 4,500 kilograms. Why did everything in the Ice Age tend to be gigantic? There are several theories. One of them is Bergmann's rule. It describes animals that can generate their own body heat, such as mammals. The colder the environment, the larger the body. Because the larger the mammals, the lower the ratio of surface area to volume, which helps them reduce heat loss. This may partly explain why so many huge and awesome species evolved during the and awesome species. Being large is a common strategy. But the diversity of species at that time proved there is more than one way to achieve the goal. Let's start with the most famous one. It is the mammoth. For most of us, the mammoth is a symbol of the Ice Age. A tall and majestic figure, traveling through huge snowdrifts, seeming indifferent to the cold. But the reality may be slightly different. Mammoths were not actually larger than modern elephants. Skeletal measurements show their shoulder height was about 3.5 meters, while some male African elephants today can reach 4 meters. Although they are similar in height, but they do have key differences. Mammoths had a warm double-layered fur, which is divided into a thicker and a longer outer layer of hair. They also have different body proportions. They were longer and shorter legs. Paleontologists believe to make it easier for them to graze without bending over too much. They also have a thick layer of fat, up to 9 centimeters thick, for warmth, and small ears covered with hair to prevent heat loss. We tried to resurrect them, but the mammoth finally went extinct. But they didn't go extinct at the same time. Now it is generally accepted there was a mammoth population on Wrangel Island, with 500 to 1,000 individuals. They survived until 4,000 years ago, which was 1,000 years later than the Giza pyramids. Next, let's introduce a more peculiar creature. They are the Glyptodons. Their name means carved teeth, because they have wide and grooved teeth, which are perfect for grinding tough vegetation. They were huge and bulky creatures, weighing up to 2 tons. They used thick legs like elephants. They walked on the American continent. They walked with their bodies protected by huge shells, like a turtle shell, making them look like distant relatives of turtles. But they can't curl into a ball. Seeing their appearance, you may think they move slowly. But recent studies show they put most of their weight on their hind legs, and even stand on 2 legs. This reminds you of even crazier pictures. A Glyptodon stands up, attack with its fake tail, or to reach food in the high places. This proves that these creatures cannot be underestimated. The following creature may surprise you, because their relatives are still around. Compared to what we see today, compared to the diversity in front of you, it's just the tip of the iceberg. The late Pleistocene sloth included 4 major families, 27 genera, and an unknown number of species. They were great dispersers, wandering across the Americas. Over time, sloths' body size tended to increase. By the late Pleistocene, nature gave birth to a group of creatures known as giant sloths. Among them, the Zhengzhishou combined the height of a giraffe and the size of an elephant. The first known sloth fossil is the American ground sloth. Its estimated weight can reach 3,800 kilograms compared to their ancestors. Our modern sloths are just a drop in the bucket. Considering the weight of these sloths, between 800 and 1,200 kilograms, this digging behavior is incredible, and also allows you to see the survival pressures they faced at that time. Scientists speculate the sloth moved underground to keep warm, or to escape the heat. Some people think it was to avoid predators. This really makes you curious. What kind of animal would want to provoke them? The most likely are saber-toothed cats or giant short-faced bears. When you witness these huge and tenacious creatures bravely facing extreme weather and giant predators and population changes, you expect to see these creatures rely on their survival instinct, successfully enter the next geological era. However, things are not so. At the end of the Pleistocene, they disappeared almost without warning. In Australia and America alone, 72 to 88% of large species were extinct. How did this happen? Why has this question been intensely debated? This question has been intensely debated. Some people think that natural climate change is the culprit. With the onset of the interglacial period, sea level began to rise, cutting off bridges and melted the ice caps, which are exactly what species need for migration. However, this explanation is not perfect because mammoths, like those on Wrangel Island, survived for a long time after this transition. Another major theory was first proposed in the 1960s. It leads us to the next focus, which is human beings. And at this moment, your journey will reach a historic moment. You will see our own ancestors for the first time. Homo sapiens evolved about 300,000 years ago, migrated out of Africa, colonized the world. This means that they lived in the Pleistocene for quite a long time, and shared the land with other creatures at that time. Because of this, paleontologists are wondering if we are responsible for the extinction of megafauna. Could this be true? Can we humans really challenge and defeat the mighty mammoth and giant sloth? Homo sapiens may have evolved 30,000 years ago, but it wasn't until the late Paleolithic period, about 50,000 years ago, they began to experience cultural development. Hunting and gathering culture reached its peak. We began to use more diverse tools, making ornaments like pendants, and devoted more energy engaging in activities beyond mere survival. For example, cave art became an outlet for humans to interpret the world. Many of the images they created are still visible today. In the late Paleolithic, the rapid improvement of tools greatly improved hunting ability. A brave Homo sapiens alone fought mammoths. The result might be bad, but what if it was a group holding sharp spears and could be thrown up to 40 meters? This created a fairer competition. One of the groups that was good at hunting were the Clovis people. They are the ancestors of the Native Americans. They had unique spearheads, the Clovis point. One of the controversies is that thousands of years after the Clovis people arrived, giant animals went extinct. So we have to wonder whether their intense hunting led to the collapse of animal populations. A study last year analyzed the only Clovis individual, the remains of the Anzac child. The study found the mammoth contributed about 40%. The Clovis people at least partially led to the extinction of megafauna, providing theoretical support. All these, how can you not be curious about the next behavior of the Clovis people and keep vigilant? In Australia, it's similar. Just before and after humans settled there, Australia also lost 85% of its large species. Paleontologists measured the size of fossils to infer the population of megafauna. They found that within 4,000 years after humans arrived, giant animal populations collapsed. Although the environment was changing before, but the arrival of humans was likely the last straw that broke the camel's back. In the late Pleistocene, another mysterious species that disappeared was Neanderthals. They disappeared about 40,000 years ago. Neanderthals were the first humans, survived in the cold glacial ecosystem. They had intelligent adaptability. They were short and sturdy, with large noses and high nasal bridges, which helped humidify the air they breathed. This is similar to the adaptation of mammoths. Contrary to popular belief, Neanderthals had a rather complex culture. With all these skills, how did they come to an end? You may have guessed it. We may also be responsible for it. Paleontologists believe either we Homo sapiens are competent, or they were absorbed by us, or they were absorbed by a larger population. In fact, most people of European and Asian descent with Neanderthals, sharing 1 to 2% of DNA. This supports the second theory. Although Neanderthals may have been losers, the image they have been given for a long time, image of being savage and backward, is unfair. Every new discovery makes us appreciate the complex cultures they left behind, language and tools. Without a doubt, the last ice age brought about tremendous development, which forever changed the history of the Earth. This is what you have witnessed on this trip. Although this era is full of uncertainty, many species can still thrive. Thriving during the Ice Age and interglacial period. When you take your mind away from the Ice Age and return to the present, I believe you must also be impressed by the biodiversity of that era. You will be impressed. Although most of those creatures have now become historical relics, their bones, caves and tombs still arouse our curiosity, suggesting a once existent world where, at least for a time, Humans lived alongside towering beasts, lived side by side with our close human relatives, and crossed the primitive wilderness together. But perhaps a more worrying question is, will this situation happen again? We are still in the Ice Age. Is the next Ice Age approaching? The Henry event we mentioned earlier happens about once every 10,000 years, which can cause cooling. They happen when large amounts of ice are dumped into the ocean. Recent data shows that, before these events occurred, there is usually a warming of the ocean, which is the reason for the instability of the ice sheet. Currently, we are seeing these signs. There may be a warning of Henry events. If it does happen, it may trigger another cooling, which is enough to trigger another ice age. So when will the next ice age come? Perhaps the answer to this question is no longer solely determined by the Milankovitch cycles. While we worry about the return of glaciers, the warming caused by human activity is like an invisible hand. We will push the timeline to an unknown distance. If we really experience another ice age, we don't know which species will survive to humans, and whether we can survive in another era dominated by ice and snow. Or will we be eliminated? Be eliminated by more adaptable species? We can't help but ask, in the distant future, what the Earth will look like, and what kind of inhabitants will there be?